Welcome to Wild Turkey Science, a podcast made possible by Turkeys for Tomorrow. I'm Dr. Marcus Lashley, Professor of Wildlife Ecology at the University of Florida.
And I'm Dr. Will Goolsby, Professor of Wildlife Ecology and Management at Auburn University. We're both lifelong hunters and devoted scientists who are passionate about hunting, managing, and researching wild turkeys.
In this podcast, we'll explore turkey research, speak to the experts in the field, and address the difficult questions related to wild turkey ecology and management.
Our goal
is to serve as your connection to wild turkey science. Well, I'm glad to see you didn't blow away.
I'm excited today. Well, I always say that at the start of every episode. I guess that tells me that I'm in the right business. But
we're excited to talk to you about this one.
But no, I've been waiting to hear, because you've been, I feel like, teasing me a little bit along with this study for, a while now.
Yeah, well,
and I really am excited about the aspect of, you paid attention to a lot of oaks species that have been otherwise neglected in the masting literature.
Yeah. Well, when you start talking about laurel oak, a lot of folks need to Google the leaves on that to even see what the species looks like, right?
Yeah.
It's just not, for some reason, it's not exciting.
Yeah.
People that study oaks don't care about it that much. I mean, there's almost no information on it, and water oak is just a little ahead of it.
Yeah, and I mean, laurel oak especially, well, I guess you're right, water oak is just a little ahead of it. Both of those tree species are kind of oftentimes looked at as weed trees.
Yeah.
In the upper and lower coastal plain.
Well, and funny you said that, we actually viewed water oak as a weed species in a different study that was going on at the same time in the uplands.
Yeah.
Because it is one of the species that was off-site invading areas that we were burning.
Yeah.
So that's as a seedling, but the oaks that we were monitoring in this study are down in the bottom.
Mm-hmm.
They're where they're supposed to be.
Right.
And I don't think that anybody would count them out as being important sources of mast for a bunch of wildlife species.
Yeah, and that's the other thing too, is like you have two species of small-seeded reds in this study, in laurel oak and water oak, and as we recently established in that episode with Dudley Phelps, those are some of the best acorn producers for turkeys because they're so available and palatable to that species.
Yeah. Yeah, it is. It was interesting to hear him say that, because I typically think of these as more of the neglected oaks, but he was pretty clear that he thought that the small seeded red oaks were the species to target for turkeys.
Yeah.
So,
and I guess that makes sense because the popularity of deer hunting and the popularity of managing for deer, a lot of times I feel like people tend to focus on the oaks that produce acorns that are, super high preference to deer. And a lot of these, small acorn reds don't really fit that bill.
Yeah. I think, that's a fair assessment. But you start talking to waterfowl enthusiasts.
Yeah.
Tune changes, doesn't it?
Well, maybe we'll change the tune for the turkey enthusiasts too.
Yeah. Well, this has been a really fun study. We started it. Let's see. We're in our 4th season now this fall.
Mm-hmm.
And I recruited a graduate student. She's moved on now. She's up in the upper west working for a game agency now. But Kelsey Demeny was the master's student that helped initiate the project and did a lot of the work out in the field, collecting acorns and running cameras and all that stuff. And I know that, that was it was a tough project. We'll just put it that way. It was a lot of work. A lot of work. Really hot, humid. It's in wetlands. There's snakes and alligators and everything else in there.
So where was the study area?
It's in kind of south central Georgia, right on in fact, the property that it's on is split by the Florida-Georgia line,
Okay.
state line. But most of the properties in Georgia, and all of the areas that we were collecting data in are in Georgia,
Mm-hmm.
in that part of the property.
Got it.
But it's in the Red Hills, which folks have probably heard us talk about that region because of the quail-centric land management. So it's open pine country, frequent fire. I think for the entirety of the Red Hills, the average fire return interval is right at 2 year.
Yeah.
So pretty incredible. You can go and look at it on a map, and it just sticks out. Pretty interesting.
Yeah, and the area is the soil is uniquely productive compared to other parts of that geography.
Yeah, it definitely was historically. You
Mm-hmm.
know, most of that landscape is post-agriculture from hundreds of
Right.
years ago.
Right.
So a lot of the topsoil, is in the Gulf now, but it is pretty productive.
Mm-hmm. Compared to deep sand.
Oh yeah.
Yeah.
It's still productive even, but it used to be even more
Yeah.
productive probably.
Right.
So, and this study was along the Osceola River drainage, which is a big water body that's kind of bisecting the Red Hills.
Mm-hmm.
So, and it actually runs right through the middle of this property that we were on. And this was a landowner that was really interested in supporting work to advance our knowledge of managing oaks beyond what we published with, from the Harper Lab.
Mm-hmm.
So I think our listeners are probably familiar with the study that we've presented in various places, and I've heard Craig Harper talk about it. I've talked about it on the air several times, and several other of the authors have as well. But that was focused on white oaks up in the southern Appalachians. And the landowner was really interested in trying to apply some of the same kind of knowledge related to releasing oaks and potentially fertilizing, different things like that we could do to manage mast production of these species that was on his property.
Right.
That's kind of where it was born.
Yeah.
And I recruited Kelsey, and that was a really phenomenal thing because she was great. She's very hardworking, and she was meticulous, and helped me set up a really awesome study. So we are tracking 800. Well, it's probably not 800 now because it just got centered by this last storm.
Yeah.
The hurricane last year hit it, and we lost about 15% of our trees in that storm. So I haven't even been there since this storm. But I'm guessing we probably lost a lot of the trees.
Yeah.
But originally we were tracking over 800 trees, and that was with a canopy mass survey, and then a subset of them, which I think was about 215 or 20 or so. We actually put mass baskets under the tree canopy and were catching the acorns.
Mm-hmm.
It also was an opportunity for me to do some other things that I find really interesting that other people kind of think I'm weird for.
I've been in that camp before.
Yeah. Well, we have a camera on a subset of the trees with the mass basket. So we have footage of this. If you're watching on YouTube, we can clip this in so that you can see what it looks like. We essentially had this basket. Acorns are falling out of the tree into the basket, and then we have people coming behind it, like Kelsey and various technicians over the years, that count all the acorns. We mark a subset of them, throw them back in, and then we have a camera monitoring wildlife activity around the canopy. So we also have a camera focused into the basket, and that one's on a time lapse, and we can basically see if anything's stealing acorns out of it.
Mm-hmm.
And we can also count mast in the basket more precisely with that. So what we now have is 3 years, and hopefully will soon be a 4th year of weekly mast counts by individual tree across 3 species.
Mm-hmm. Water oak, laurel oak, and swamp chestnut.
Yeah. Which are the 3 that are most common there.
Right.
Swamp chestnut in the bottom is the only one that's really common. There are post oaks, but they're kind of farther up into the oakland,
Mm-hmm.
and then live oaks are same.
Yeah.
So really cool study, and the plan is to have 8 years total,
Okay.
and
Just to try to capture all that annual variation.
yeah, and the plan is to the plan was to implement some treatments at year 4.
Mm-hmm.
So we would be doing that, but I'm afraid that the hurricane has probably wiped that slate clean.
Yeah.
So we will see how that works out. But the idea was that we could track all these individual oaks, identify what we're colloquially calling the super producers.
Mm-hmm.
So the individuals that are producing the majority of mast,
Right.
and then apply some treatments. And it wasn't to demonstrate that it increases oak masting. I think we pretty well ironed that out with Harper's study, and there's been some others that have done similar work that thinning, releasing those trees from competition is going to increase their investment in mass production.
Right. By allowing the canopy to expand out.
Yeah. But what is relatively unknown is how it affects the timing and synchrony of masting.
Mm-hmm. Well,
So
that's an interesting spin.
Yeah, that's what we're focused on with the long-term project.
So basically, whether canopy release changes the timing.
Yeah.
Okay.
And
Never
based
thought about it that way.
Some of the literature in the fruiting industry, like particularly the one I'm interested in is pecans, suggest that it will move the timing of the individual.
Earlier or later?
Earlier.
Mm-hmm. I could see that. That would be just off the cuff my initial hypothesis that it would move it earlier.
Yeah, that's what the primary hypothesis we're testing. But I took it as an opportunity also to just get some really good information on 2 oak species. Well, actually, all 3.
Yeah.
All 3 of the oak species basically don't have any data on their masting.
Right. Well, let's jump into it. I'm excited to hear about it.
So this first paper, this was Kelsey's main chapter in her thesis, and it's representing the first 2 years of data from that. And if you look at figure 2, that's really telling the story to me.
Yep. I gravitated immediately towards that figure.
So for those that are watching on YouTube, you can see it, and I'll describe it for everyone else. The colors, so the yellow bars are 2021 data, and the blue bars are 2022. And you can see the timing of the oaks in this. So when are they producing mast within the fall season? And water oak, if you look in 2021, it was right where I would have put it, right? The peak in masting in that year was late November and kind of trailed into December.
Yeah,
Right. Basically Thanksgiving. The same thing was true on laurel oak and swamp chestnut oak. They both kind of timed the same time.
Right around Thanksgiving.
Yeah. But then we kind of threw a curveball in here. We look at 2022, and this was a big mast year. And a couple of things happened. One, the timing changed. I don't know if you noticed that, but water oak was a couple weeks earlier.
Yeah, it shifted to earlier for sure.
Yeah. And same thing on laurel oak, it shifted earlier. And then we basically had a mast failure on swamp chestnut oak.
Right.
But all of the acorns that we detected pretty much were way earlier, which I think is probably because it was mainly aborted acorns. So to me, that's really interesting, and I now know what the 2023 data looks like, and I can say the oaks remain asynchronous across years.
Okay.
They're changing the timing.
So what about within a species? How did the timing change in 2023?
That's what it it's offset again
Okay.
from the
Earlier or
water
later?
later.
Okay. So back to the end of November?
I think it'd probably be right centered on Thanksgiving again.
Okay. So do you think that long-term average would reveal that it's closer to the end of November or the beginning of November?
I would say toward the end of November on the
Okay.
long term average,
Okay.
maybe the third week of November.
And that's for both water oak and laurel oak.
Yeah.
And what about, I'm looking at
Well, it's going to be probably be that for swamp chestnut, but we've had 2 mast failures in a row on swamp
yeah,
chestnut.
that's what I was going to say. I was going to ask you about the upper panel in that figure. Do you think that you've actually captured a good production year for swamp chestnut oak yet?
No, we would have last year, but we got centered with a hurricane. So all the mast fell in August last year because it
Right.
got knocked off the trees.
Right.
So, and this year will be a mast failure as well because it got centered by Helene,
Yeah.
which is interesting in and of itself.
Yeah.
But there's actually, to my knowledge, not much data on how oaks respond to high wind events like that.
Look for that paper in a couple of years because you'll have
Yeah.
it.
Yep. So we now have 2 hurricane.
Well, that's what I was
events out of
thinking
4
earlier.
years.
That's what I was thinking earlier is, since those hurricanes have come through, now you have a natural experiment not only to look at the effect of major wind events, but then also certainly probably some of those trees got released, by the
Yep.
hurricane.
That's what's going to happen.
Yeah.
We were already planning that because so many got released last year
Yeah.
that we basically had planned, instead of us implementing a release treatment, we're just going to take advantage of Mother Nature.
Yeah. And just so to make sure that the audience understands what I have in mind when I talk about release is killing or felling any surrounding trees that have canopies interacting with the mass producing trees canopy.
That's right. And the storm did a lot of that for us.
Mm-hmm.
For all I know, we don't have any oaks left because we are
Yeah.
not able to get on the site yet because we're
Yeah.
recording right after Helene
Yeah.
came through. For those
I mean,
out there wondering,
it's a natural disturbance event. I
Yeah.
almost hesitate to talk about it that way because I worry that you run the risk of making light of a situation
Right.
that, negatively impacted so many people and their forest resources and things like that.
Yeah, it's a devastating event.
Yeah.
I mean,
Yeah. But ecologically, I mean, it's kind of the way, early succession was implemented across the landscape historically. Um,
Yep.
and I even got a listener question this week about, what actually I had one last week about the big pine beetle outbreak this summer in Alabama and how that was a natural disturbance event that was going to reduce the canopy in some areas. And then, we had this hurricane come along, and I've gotten a couple of questions about, do I think that's going to help turkeys? And I said, well, I mean, if it's an area where, canopy cover is a limiting factor, meaning that it's not open enough to provide the structure and vegetation that they need at ground level, then it seems reasonable to assume that it potentially could be a positive
Yeah.
from that habitat perspective.
Yep. And it's like you said, a natural way that occurs on the
Right.
landscape.
Right.
It
The
doesn't change that it's not devastating to people
Sure.
and property, but
Yeah. I mean, we would rather implement that canopy disturbance ourselves, right, in a controlled
sure.
manner. Um, but anyways, I digress.
Yeah. So, uh, yeah, that I also have some data on these oaks. Getting back to this with synchrony, which we just had a deep dive synchrony episode, so folks might be sick of synchrony. Now we're talking about it even to the individual.
Mm-hmm.
The something that's pretty remarkable to me like with water oak in particular, that's the one we have the majority of the data on because most of
Right.
this is the dominant tree in the system.
Right. I've got an exciting announcement today from our friends at Grounded Brand. They have decided to offer a 10% discount to Wild Turkey Science listeners. So if you go to groundedbrand.com, you can choose from a variety of apparel and turkey hunting gear that they have available. It's really nice looking stuff. And just enter the code Turkey Science, all one word at checkout, and you'll get 10% off.
When you look at the good mast year 2022, notice that there's a lot of mast being produced from mid-September all the way until mid-December.
Yeah.
Like there's a clear peak this in November, but there's a lot of acorns falling off the tree across that. So
yeah, I noticed that too. So for water oak in 2022, there was a little peak around the third week of September, and the magnitude of that peak was almost, I don't know, what do you think, Marcus? Maybe like 75% as high as it was for laurel oak's best peak of any year.
yeah.
And it was that early peak. So, I mean, it would be easy if you were a hunter out there and you found that tree to assume, oh, this thing's raining down right now. But truth be told, if you had come back at the beginning of November, it was orders of magnitude higher.
Yeah.
And it wasn't this linear increase over time. It was pulses.
Yeah. So when you actually go into the data set, which we're working on this right now, and I have some key questions that I want to answer because I think it's fascinating. But if you look at the individual oaks that are making up that distribution, right?
Mm-hmm.
So we've got this pattern of the whole population. If you look at the individuals within that, we have individuals in the population that their peak masting is in late September, and we have individuals that their peak masting was in mid-December.
Okay.
And everywhere in the middle.
Okay. So that wasn't, so maybe I misinterpreted the data in the sense that those were individual trees contributing to that spike. It wasn't like all the trees dropped some the third week of September, but then they dropped more in November. Am I explaining that well?
Well, you're right. I was telling you a little different version of that story, but what you said is also correct.
Okay.
So the other thing I found remarkable is some individual trees don't have a peak. They just start producing in September and just trickle them out all the way to December.
Yeah.
And then other ones like put all in on 1 week.
Well, that's the interesting thing about it is I've always thought of water oaks as that type of mass producer where they kind of start, like in bow season and they just trickle all the way through deer season.
Yeah. Well, there were some individuals that did that.
Okay.
So, it's hard for me to tell you the simple story because it isn't simple. Like every individual seems to have its own strategy.
Well, that's why we created a podcast so we can have time to talk about nuanced
The deep
topics.
dive.
So let's do it.
So I just find that interesting, and that's not published yet. We're still working on the analyses, but it is pretty clear to me that there's a lot of individual variation in the timing and how protracted that season is, right? How long the season is. You can see from the data, or you might surmise from the data, that in the better year that tends to have a longer masting season in general.
Mm-hmm. Yeah.
And part of that is because the individual trees have a longer masting season when they have more acorns on them. But I just found it remarkable that there seem to be individuals doing their own thing in that population.
Yeah.
And with water oak, that's over 100 tree species, tree individuals represented. So
solid
pretty good
sample size. Yeah.
So that to me made me want to start looking under the hood to see, supposedly they're all supposed to be synchronized.
Right.
Which they generally are on year, but when you look within the season, that doesn't seem to be true anymore.
Right.
So, if you look at the second part of that figure, this is the metric that most people probably care the most about, water oak in both years were the most productive
Right.
out of the three oak species.
Mm-hmm.
They were producing, let's see, 9 to 13 number of acorns per square meter of canopy.
Okay.
So that's a pretty typical measurement.
Yeah, so you
Uh,
take a 3 by 3 foot area of the canopy, and you're going to have between 9 and 12 acorns in that area.
yeah, on average.
Right.
We had some that were quote unquote super producers
Mm-hmm.
where they had like 50.
That's what I mean. I feel like I would have expected a higher number than 9 to 12 or 9 to 13, whatever it was.
Yeah. Well, I didn't know what to expect, but I think it's really interesting to look
I'm
at
just,
it.
I'm just going off the cuff, but
Well,
then
in Mariah Bogus's work that we've talked about, where we had to calculate the number of acorns that we
mhm,
should expect to be in a canopy of a good producer in a good
yeah,
year, and you know, even though the mean was something like this for per square meter of canopy, when you extrapolate that to the whole canopy, it was still hundreds of acorns for that tree.
mhm. Yeah, I think part of our, or at least I'll speak for myself, part of my bias in thinking that the number would have been much higher is that as hunters, we tend to focus on the really productive ones, right? Those are the
Mm-hmm.
ones that are going to stand out as this is a good spot to set up versus,
Right.
one that just has a handful of acorns that it's trickling. But then if you think about, population level effects, like for turkeys, um, the additive effect of having many, many of those trees producing, moderate amounts, is going to be significant.
Mm-hmm.
So, like, they may not be. I think the hunter always thinks of a tree, an individual oak tree, as an attractant, right?
Yeah.
Versus thinking about it as, yeah, we need those low to moderate producers in large numbers across the entire area because that's contributing to the actual, food availability at the landscape scale.
Yeah. Well, I think the best case scenario is to have both, right?
Sure.
Like I really want that those couple of individual oaks that are reining it down
Right.
really early because they're going to be super attractive.
Right.
But, I also want my turkeys and deer and whatever else to have food all the way through the winter.
Yeah. It would be interesting to do some work, and of course, think about how much time this would take to complete this experiment, but to propagate some of those earlier producing individuals and see if that trait is heritable,
Yeah.
and is conserved among its offspring. Do its offspring actually continue to produce early, or is it something about where that tree is situated that's driving that?
Well, that's one of the analyses that we are working on now. We really need another big year, and we thought this was going to be it until Helene wiped us clean. Uh, one of the analyses that we were working on is whether or not individuals are consistent. So, yeah, this oak rained it down in September this year. Will it also do that next year
Yeah.
relative to everybody else, or are they kind of changing because the timing at the population level doesn't seem to be consistent?
Yeah. But even if you still had that consistency of one individual from year to year, you still don't know what it is about that individual that's causing
Right.
that, right?
That's right.
It could be genetic, it could be environmental.
Yep. And we have a number of things that we've measured trying to see if we can predict it.
Right.
But right now, I don't know.
Right.
I just think it's interesting because I've never thought about oak masting this way.
Yeah.
I've never thought, oh, well, I've always thought about it like, oh, white oaks are going to be raining it down in early November.
Mhm.
Be ready.
Mhm.
But I may be thinking of an average
Yeah.
or an individual.
Yeah. And I think this is why us hunters get so confused oftentimes when we're scouting, and what we're seeing in the woods at individual trees doesn't align with maybe something that we've read in a hunting magazine about this being a banner acorn production year,
Yeah.
or a below average. Both situations have happened to me in the past.
Mm-hmm.
And it's because those forecasts or those mass surveys speak to averages, not to individuals.
Yeah. But you know, as we've had an interesting discussion, or at least I've found it interesting discussion here, the individual variability is interesting.
It is, yeah.
So the wildlife response, you made a thing of it before the show
I
that
know
we
where
didn't
this
have
is going.
turkeys in here. We didn't have enough data on turkeys. That was one of the 4 species. Actually, that one and also pigs we were interested in doing, and we don't have either of those represented, and that's because the number of detections to date, as from the first 2 years, was not sufficient to do
Right.
analyses on those two. So it may be now that we're going to have 4 years of data, but it's not. It wasn't at the time that we published this.
Sure.
So, I guess the take home messages from this, if you look at Figure 3, it's color coding it based on the species of wildlife.
Mm-hmm. And so y'all had
And
cameras set up around all these trees?
yeah, so we're basically monitoring use of each individual that we're monitoring, how many acorns by week it's producing.
Mm-hmm. Where were the cameras? Were they just like looking at the area around the base of the tree?
Yes, a lot of them we were using the oak as the base of the camera and kind
Okay.
of monitoring out. And then in some cases, the tree's too big or whatever, wasn't a good position, and we have it on an adjacent tree. But we're trying to monitor the area under the drip line of the
Okay.
tree.
Got it.
So you can see some general patterns, I guess, in use. Even though swamp chestnut oak was not nearly as productive in terms of the number of acorns, that still was where deer use was concentrated.
Right.
So squirrels were a little, we talked about this earlier. I don't know if we have it recorded or not, but squirrels did not focus on swamp chestnut oak like I thought they would.
Right.
We even have some videos of them actually holding one. The acorn is about the size of the squirrel's head.
Yeah.
Like it's
It's ambitious.
So yeah. So like it's difficult for it to carry that thing around, I guess. But they tended to focus on the 2 red oak species, but particularly water oak.
Mm-hmm.
With raccoons, which we had quite a few detections of, there wasn't really that strongest selection across species for them.
Yeah.
But the same sort of selective gradient that most people would expect, I guess, for deer was present. What would you expect turkeys to do?
I would think that they would gravitate towards, for the reasons that we talked about earlier, acorn size, more so towards the water and laurel oaks.
Yeah, I agree with you.
Because I mean, it seems like you've got some data that at least indicates we can't, it's not causality, but at least indicates that even squirrels, who obviously can use their teeth to cut into an acorn, preferred smaller acorns. So, like with a turkey, you would think that bias would be even stronger towards the smaller acorns.
That's right.
But another thing that just popped up in my mind as we were going through this that was interesting to me is if you look at deer use, okay? So in panel A of Figure 3, it's about 2 times, so that we're looking at the average number of observations on a weekly basis of deer. Yep. It's about 2, like, I don't know, what is it, 1.5 to 2 times greater for swamp chestnut as opposed to water oak.
Yep. Even though there was far more mast available.
Yeah, well, that's what I was going to say is most hunters, if they put a trail camera out and, like by a water oak versus by a swamp chestnut, for the reason that you just mentioned, they may not capture that many turkey images, right? So maybe they're using deer images instead as an indicator of preference. And if they saw that deer were visiting the swamp chestnut at 1.5 to 2 times the rate as they were the water oak, that might, lead someone, including me, right, to believe that swamp chestnut oak has an outsized importance ecologically as opposed to water oak. But then you flip back up to figure 2, like you just mentioned, and you're looking at the production of those acorns being like over 4-fold greater than it was for swamp chestnut. So water oak is producing 4 times the amount of acorns per square meter than swamp chestnut. It just happens that swamp chestnut is much more attractive.
That's right.
So which one is better?
Well, it depends on if you're holding a bow, I guess.
I mean, I just did that to,
Yeah.
Because that's a false dichotomy that I created, right? Like neither one is better.
Yeah. I think the answer is yes.
Yes.
You want both.
If you want to shoot a deer with a bow, hunt the chestnut oak.
Chestnut oak.
The swamp chestnut oak. If you're focused on the number of, I dropped off the swamp part and took for granted that audience would stay with me on that, but that is an important distinction to make. Very, very different species ecologically.
Yeah.
But yeah, so like anyway, if you're just trying to shoot a deer with a bow, go for the swamp chestnut oak. If you're looking at, overall calories that are being produced and are available to be consumed by turkeys, water oak.
Yeah. I agree. The other thing that's really interesting, just me knowing the site and, walking around with Kelsey several times out there when, she was doing this stuff. It's not even that they're more productive per capita. There's way more individuals of those.
Sure. Absolutely.
Like they are the dominant tree in that system.
Yeah. I mean, any property that you go out on in that part of the world, you're going to find, I don't know. I mean, I'm going to probably run the risk of overstating it, but 100 water oaks for every swamp chestnut oak you see.
Yeah, I'd say usually they're distributed like that, right? That you have water oak would be one of them, but you have several oak species that are going to be dominant.
Right.
And then the swamp chestnut oak would be more of the rare. There's definitely places. We're going to get emails about this.
I know.
There's places that swamp chestnut oak is the dominant oak.
Yeah. But oftentimes on those properties,
great.
When you see a swamp chestnut oak as you're driving around, you make note of it because you don't see it that often.
Right. I would say less than 5% of the trees in this drainage are swamp chestnut oak.
Mm-hmm.
So they're relatively rare. Also, finding an individual that is highly productive is rare. Right? And also, the acorn on that sucker is huge, which is also rare.
Mm-hmm.
So I guess I'm trying to make the point here in terms of attractiveness. It is most likely the rarity that's making it so attractive.
Sure.
Like the deer can just walk around and eat water oak acorns everywhere.
Yeah.
But they may be getting something different out of that swamp chestnut oak that it's causing them to seek it out when it's available.
Mm-hmm.
And I think that the data show that.
Yeah. And just generally speaking too, we know that white oak acorns tend to be more palatable.
Yep. Man, we've got some good videos. Maybe if Charlotte has them handy, she can splice some in.
Yeah.
Like watching deer try to take down one of these swamp chestnut oaks. We've got a couple of videos where their mouth is like right in the camera.
Yeah. Is it like watching a horse
eating a baseball?
Like a horse eating an apple?
Yeah. That's exactly what it looks like. We've got a couple with squirrels trying to carry one off to bury it or something.
Yeah.
It's funny. But, to me, this project is just going to continue to develop, right? Like, there's so many cool aspects. I know we're probably leaving a lot of questions on the table that people are out there typing into YouTube right now, some comment about how we didn't cover it, and that's fine. But this is 2 years into an 8-year project,
Right.
and
It's important to keep that in mind.
I think we've got lots of things to learn, not just about those species that we don't have much data on, but also the only publication that I'm aware of that's looked at this temporal resolution with masting is this one.
Yeah.
So, I think trying to learn about how synchronous they are within the year, how that's affecting the wildlife species we care about, how the individuals are distributing themselves in the population, whether or not they're consistent, all those kinds of things are at large questions that I think we're going to be able to answer here well.
Well, and even the more well-studied species of oaks, like the ones that are more common in the southern Appalachians, most of the papers that I've come across, and maybe that's my own selection bias based off what I'm looking for when I go search out those papers, but still most of them I feel like report more so on annual production, and they don't break it down to these finer time scales, meaning like they don't break it down by month or by week even.
Yeah, that's what I'm saying. There are no other papers that I'm aware of that have broken it down at a finer resolution.
Right.
And I think that's important, especially for me as a hunter. I want to know when the white oak is dropping.
Yeah.
Not which year it's going to drop.
Absolutely. Yeah, 100%. And then, taking off the hunter hat and put on the ecologist hat and the land manager hat, right? You're trying to figure out how these various species complement each other. Like what roles are each of them respectively filling on the landscape? How does that fit together? And then we can translate that into better landscape level management practices.
That's right. And even taking another a step to the side, but still back, like you just did, what is the role that the variability within the species is playing?
Yeah.
Like water oak, the masting season is 3 months long because of the individual variability for one species.
Yeah.
And then you overlay 10 species, and all of a sudden we've got a pretty well-fed wildlife population.
Yeah.
Right?
I mean, I think that's what it boils down to.
Yeah. So we have talked about that, and I hear this talked about how the diversity of oak species is important to stabilize the food availability, but I think the individual variation within the species is also important.
Yeah, and I've thought about it much more simply in the past, in the sense that, the 2-year cycle versus 1-year cycle of production among the two different subgenera, and buffering against the effects of a late frost or a failure or a poor production year in one group versus the other. But this lends even another level of consideration to that, in that it's not just, buffering against failure years or poor production years, but also just ensuring continuous availability of an important food resource throughout a time of the year where food sources are otherwise limiting for many species of wildlife, including turkeys.
Yep. Well put.
Thank you.
Well, I can't thank Kelsey enough. I know we don't normally give graduate students their due respect, and she deserves a lot for this project because, man, it was a beast.
I bet it was.
And we've had a postdoc, David Mason, that was on it, and now we have a new postdoc, Alex Potash, that's on it.
Yeah. These are data that you have to grind for.
Yeah, for years. It's not even really that interesting until we get several years of data.
It's not, and it's like, this is like the worst data to have to collect, but then it's some of the funnest data on the back end. Can I say funnest on a science
funnest,
podcast?
I think that's a good word.
I don't know. I'll throw it out there. This is, but like,
it was the funnest data that I've
seeing the results certainly are, but the process of going through it's the worst.
Well, I think one of the reasons that it's funnest is, it's grueling to collect, and that, it sucks at the time. but it also has some really major implications for management.
Mm-hmm.
And I think that's where we intersect. Like, there's some really cool ecology, really hard to get the data, but man, some really good stuff from a management perspective.
Kind of zooming out for a second, how many oak masting papers have there even been from the lower coastal plain of the South?
I that's what I was saying. I can't even find one on water oak
On
and laurel
any
oak.
topic related to acorn production.
Mm-mm.
Yeah. I mean, and I understand why. I mean, there's a greater diversity of food resources typically that, follow from land management practices in the lower coastal plain as opposed to, getting up into the ridge and valley,
Yeah.
for example.
Well, you look at this study area, this is a perfect example. That whole region, people don't care about oak. They're a nuisance.
Mm-hmm. But this can show the important ecological role that they still fill.
Yeah.
I mean, it doesn't show it directly because you're not actually looking at wildlife vital rate responses or anything like that, but intuitively, it plays a role. Like if you've got,
Yeah.
I don't need to belabor it any further than I have, but it's
Well,
easy for us to forget about them, in certain places,
Right.
but they still play a vital role.
Well, that's what I was pointing out. In the landscape they're in, the land use is being driven by other species that the oaks do not matter to or might be negative to.
Yeah.
So, I think that's part of the reason why there's just not that much data on them.
Sure.
There could be papers published on it, but it is, if they are present, it's rare.
Mm-hmm.
We'll just put it that way.
Well, that was really cool. I enjoyed learning about it. I'm glad y'all did the work.
Yeah. Well, I'm glad it's still going. Glad I still got a good team of folks to continue doing this, because I certainly can't spend my days out there collecting acorns. I got a podcast to do,
Oh man, all of your staff's eyes collectively rolled at that statement.
Hey, they're having fun too.
They are.
Don't let them fool you. All right. Well, you ready to wrap this one up?
I think so. Do we have anything else we needed to announce or mention? I'm trying to think. Nothing comes to mind immediately.
And we're right in the middle of October right now.
October. You got that 100th episode coming up.
October. I actually think this one's going to be 101.
Oh, is it? We've actually, for y'all's edification, is that right? I don't know. We're gonna go with it. Pretend it didn't happen.
I'm prepared to be edified.
Okay. For y'all's information and edification, we've actually been a little bit more on top of recording lately. We're out ahead. So
yeah,
I need to stop, dating these episodes because it's going to get confusing to people.
Yep. Well, hopefully folks are still listening. If you are, let me take a moment to say thank you. Appreciate it. Glad you're sticking with us. Hope you continue to. And if you haven't rated the podcast, please take a moment to do that. We really appreciate all the support. And another October episode.
Let's go. Wild Turkey Science is part of the Natural Resources University podcast network and is made possible by Turkeys for Tomorrow, a grassroots organization dedicated to the wild turkey. To learn more about TFT, check out turkeysfortomorrow.org.